Question 3, you have a diagram that shows a body of mass 10 kg attached to one end of a string hung over a frictionless pulley. The other end of the string has a body of mass 16 kg attached. Now for easy referencing, I'm just going to call the 16 kg mass P and the 10 kg mass Q as indicated in the diagram. Find the tension T in the string and the acceleration of each body once the system is released. On top of Newton's second law, F net equals to ma, there are two other key ideas that we're applying for this question. Okay, the first being the tension on both masses are equal because they're connected using the same string. So if P experiences a certain tension in the upward direction, then Q also experiences a tension of the same magnitude, okay, also away from body Q. Next key concept is that since the bodies are connected with a piece of string, as body P moves, body Q must move with the same acceleration. So when body P accelerates downwards, because Q is connected, Q will accelerate upwards with the same acceleration. We're just going to quickly take a look at the simulation that we have seen in our previous lesson, this one. Okay, unfortunately for this simulation, I cannot choose a 16 kg. It doesn't go up to that kind of magnitude. Okay, but I'm just going to choose a larger mass over here and a smaller mass on the right-hand side. So when you release the masses, you'll find that when M2 accelerates down, M1 will accelerate up. And because this string over here, it connects masses M1 and M2. So the speed of the objects at any one time must be equal, and therefore their acceleration must have the same magnitude. So we're going to transfer all this information into a free body diagram. So body P accelerates downwards with acceleration A. Body Q accelerates upwards with the same magnitude of acceleration. Body P is 16 kg, so it has a weight of 16 times 10, 160 newtons, pointing vertically downwards. At the same time, P is also experiencing a tension pointing away from it in the upward direction. Q experiences a tension pointing away from it, the same magnitude of tension, and it experiences its own weight in a downward direction. Since the mass is 10 kg, the weight will be 10 times 10 equals to 100 newtons. So now that we have the free body diagram, we can go ahead and apply Newton's second law on bodies P and Q. Considering body P, since the acceleration is in the downward direction, I'm going to take downwards as positive for body P. F net in the downward direction on P causes the mass of P to accelerate downwards. Okay, so let's take a look at what are all the forces acting on P. It has the weight in the downward direction and tension in the upward direction. So the net force downward will be 160 minus T, causing its own mass of 16 kg to accelerate. Now we consider body Q. F net on body Q causes the mass of Q to accelerate. This time around, the acceleration is in the upward direction. So in the upward direction, it has a tension. In the downward direction, it has a weight of 100 newtons. So the net force in the upward direction must be T minus 100 equals to mass of Q, that's 10 kg, multiplied by its acceleration A. So you see we have obtained two equations and we have two unknowns. So we need to solve for simultaneous equation. Your calculator does come with this function. I'm going to demonstrate how to use it. The first thing you need to do is to rearrange your equations such that they are in the same sequence. Okay, so for example, t comes first, followed by a, followed by the constant on the right hand side. Okay, let me show you what I mean. So for example, this equation, rearranging, I get t plus 16a equals to 160. And for the equation for q, I get t minus 10a equals to 100. So notice that when I'm arranging the equation, okay, t comes first for both of them, okay, followed by a, followed by the constants on the right hand side. Later, when you're keying in the calculator, what you need to key in are the coefficients of t, coefficient of a, as well as the constant on the right hand side. So the first equation will be 1t, 1 is the coefficient of t, plus 16a, so plus 16 is the coefficient of a, and that equals to 160. For the second equation, it will be 1t minus 10a equals to 100. So these numbers that are circled, these will be the numbers that you're going to enter into the calculator. It looks like that. So under setup, choose equation, that's 5. And then simultaneous equation, that's 1. And we have two unknowns. And from there, key in the coefficient of the first variable, that's tension. Second variable, that's acceleration. And the constants on the right-hand side. Do the same for both equations. And it'll tell you that your first variable, that's in this case is your tension, is 1, 2, 3 newtons. And your second variable, in this case, it is your acceleration, is 2.3 meters per second squared. So once you come to this step, you can then write the final answer. T equals to 1, 2, 3 newtons, and A is 2.3 meters per second squared. So in summary, what we have done, okay, to approach Newton's second law, questions involving Newton's second law, draw your free body diagram, label all the forces acting on the object, apply F net equals to MA, and when you're calculating F net, remember that it's a vector sum. So do take note of the sign convention. I would take the direction of acceleration to be the positive direction. And lastly, solve and check to see whether your answer does give you the net force in the direction of acceleration.